Hi, in this video I'm going to continue the work I have in last week and complete a few more pivot flow, and then now we got a end-to-end machine learning workflow in our data view system, which means that it starts from the raw data, doing the data processing transformation, and then we have models in this workflow as well to train the data. And then we got the model performance based on the training data. And then we also have a prediction going on as well with the testing data we have. So, as you can see, there are many things here in this workflow. So this workflow has three inputs. The first three are different data sources. They are raw files. So for example, for the bike raw CSV, which is the CSV files we have for the bike data, specifically the New York City bike data. That's from 2013 July to the 2017 July, so almost 4 years of data, around 8 gigabyte. And holiday data is the US holiday. We have put that in a CSV file as well. So that's all the common holiday like Christmas, Thanksgiving, etc. And the third one is the weather data, which is the daily weather information, which including rain, snow, wind, and so on. For the same date, we have for the extract information we got from the bike. So the main idea here is the problem we are trying to solve is we try to see, given all those data, and whether we can use the weather factors in the weather data to make prediction of the number of the daily trips we are expecting for the bike for the days which are non-holiday, non-weekend, so only weekday. So that's the main idea of this workflow try to solve. And this fourth input is the input required for another P workflow. We will talk about that later. So let's start from the top pipeline over here. This is mainly for the bike data processing. So as we know, when we got the raw file, there are many things going on. The data may be dirty, the quality may be low, the format may be not consistent. Those all kinds of problems exist in the data we have. So that's why we need to have this pipeline to do some data cleaning, data transformation work. So the first one is we use this one to generate all the daily trip information, which includes date and the number of the trip for the day from the raw file. So this one pretty much doing a lot of heavy lifting work to extract the data sets which is meaningful for the problem we are trying to solve over here. And the second one is try to format the date. As I mentioned before, the date format, even within this one data set, they are not consistent. So we need to have a consistent format for later use. And then we add the day of the week into this data set based on the date we have. And then we split the date to year and month. And then we using the holiday data to filter out from the bike data only the weekday of the bike. But as we can see, we're also doing another format for the holiday to format some date format and other things. Just make sure these two data sets are union compatible, so that we can draw union and filter based on certain fields. if the fields are not consistent, it's hard to do that. And then we're gonna merge this with the weather data, and then we got our kind of like the merged daily trip data with the weather. So in this one, we're gonna have the date, number of trips, year, month, and as well as the week of the day, and then all the weather information. And for the weather, this pipeline is doing the weather processing. So first of all, we still format the date in order to be consistent along 3 sources, and then we drop some extra column we don't really need in this analysis, and then we fill out some missing data we have, because some the column they have missing data is empty. So the way we are doing it over here, we just fill that with the default value, because those are either one column is binary, another one is just missing the value for the 0 value columns. So until here, we are done with the data processing, and then we start to go into the machine learning pipeline. And then these inputs come in because we randomly split the data set we have over here into 2 parts. One, so right now the ratio is 80%, so we split that into 2 parts. One is 80% of the size of the data we have, the other one is 20%. So we're gonna use the 80% for training and the 20% for testing. So as we can see over here, this branch is the training branch, this one is the testing. And then we have this 2P workflow over here, try to convert from the CSV format to the ARP formats, because we use Weka as the API for machine learning in DataView. And then we come into 4 different models. One is the SVM regression, which is using the SVM to do the regression. And the other one is REP tree, which is a decision tree learning algorithm for regression. And the third one is linear regression. And the first one is the M5P. M5P is also a decision tree algorithm for regression, but other than the REP tree, which is building a regression tree, meaning each of the leaf nodes in this tree is basically just the prediction. But for M5P, each of the leaf is another linear regression model to do the prediction. So that's why sometimes this was also called regression tree, and the M5P was called the model tree. Just a little bit difference here. And then for the testing part, it's nothing but just fit to the second input of each model. And another thing I want to point out is each of the model over here we implemented in DataView, it has the built-in cross-validation for the training. So meaning for each of this model, the training set coming in, 10-fold cross-validation was done for the training part, so that it can help us to get better estimation of the model performance during the training. And there are 2 other workflow, P workflow over here is nothing but change the column type from the numeric to nominal, because these 2 models can also take nominal. And then we have another P workflow here, try to help us to select the best performed model based on the training. And this is using 2 metrics we have. One is the R-square, which is explaining how well the variant of the data set can be predicted by the model. And the other one is the mean absolute error basically tells us how accurate your regression is doing the job. And then we output the model over here. And then for the other 4 outputs, it's the prediction each of the model was doing using the testing data. Remember, we have 20%, so this one goes to the second input of each of the model. So this is pretty much a high-level explanation of what's going on for this workflow, and then I will show some sample output as well. So as we can see over here, this is one of the output for one of the models. So this is the M5P, linear regression, SVM, REP, and we're also gonna have the model selection based on the R-square and as well as the absolute mean error. Thank you.